Let's see a typical injection molding operation, the molding of combs. They're made in a mold that splits in two to allow their removal. The raw material, polypropylene granules, is loaded into the hopper. From here it falls into a measuring device that controls the rate of feeding to the machine. As the injection plunger moves forward, the mold is filled, and at the same time a little more material falls into the heating cylinder. There's enough material in the machine for several shots, and it heats up gradually as it moves along the cylinder. Some material freezes in the mold channels and has to be cut away from the molding. It isn't wasted, it can be used again. In some machines, the material falls onto a rotating screw. The screw mixes and pushes forward material through the heating cylinder until enough is available for the next shot. Then it moves forward, acting as a plunger, to inject the heat-softened material into the mold. Using a screw in this way is called pre-plasticization. In the cool mold, the material freezes in shape and is ejected as a molding. Once the controls are set, the machines function automatically, except for the removal of moldings. Large or small, simple or complicated, moldings are produced at the touch of a button. Another process, and a most important one, is extrusion. Extrusion of thermoplastics, the same materials that are used in injection molding. It's a continuous process like using a sausage machine or a meat mincer. The screw in a close-fitting hot barrel forces the heat-softened material through a die. It's the profile of the die that gives the final extruded shape. Heat to soften the material is provided by electrical heating bands around the barrel, kept at a set temperature by control instruments. From the hopper, the material is moved along the heated barrel by the screw, and then it's forced through the die. This is small diameter tube, and in the same way you can make PVC hose pipe. It's tough and doesn't deteriorate like rubber. Large bore pipe would sag and collapse as it comes out of the die, but it's held in shape inside a water-cooled collar by having compressed air inside the pipe itself. Apart from its uses for water mains and industrial pipelines, you can slit it in half down its length to get house guttering. Fluorescent lighting fittings can be made by an extrusion process coupled to a simple forming device. As the material extrudes in the form of a large tube, it is slit by a small knife on the die face. And then it's formed by inside and outside shapers and cools as it moves along. The haul-off gear keeps the section moving at the speed of extrusion. Even bottles are made by extrusion. An extruding tube falls over a spigot through which compressed air will blow the tube into the shape of the mold. In only a few years, plastic bottles have become as familiar as glass. Polythene film is made by extrusion. The melt extrudes vertically as a large thin-walled tube. It's cooled by a circular jet of air, but before it freezes, the tube is expanded by air pressure and stretched vertically to give the required film thickness. Another method of making film is by using a long, narrow die. Here the film, polythene, is being laminated to paper. It falls between two pressure rollers. The paper passes between the same pressure rollers and becomes coated with the polythene. After cooling, the edges are trimmed and the coated paper is reeled up. Sacks made from coated paper protect the contents from moisture. Wire and cable covering is a very large outlet for plastics. The bare wire is fed through the center of the die and the plastic extrudes round it. A water bath cools the wire before reeling up. Extrusion-coated wire is used in every branch of the electrical industry, from house wiring to submarine cables.